Okay, so welcome. Today we're going to talk about some probability questions. We're going to do a little review. I've pulled out some past used probability questions from tests, exams, and we're going to see if we can't work them out. First thing I'm going to make a suggestion is that when you're going through these, read through them and make sure you've got a clear idea of what's happening. So it says to gain a place in science college, students first have to pass a written test and then a practical test. So clearly we've got two tests, a written test and a practical test. Now, each student is allowed a maximum of 2 attempts on the written test. A student is only allowed a second attempt if they fail the first attempt. So if you passed it, well, then you don't get a second attempt, which that only kind of makes sense. So you're only going to get a second attempt on the written test if you fail the first attempt. No student is allowed more than 1 attempt at the practical test. Only 1 attempt on the practical. If a student fails both attempts of the written, then he cannot attempt the practical. So you've got 2 chances to take the written. If you pass the written, then you take the practical, and you only get 1 attempt on the practical. The probability the student will pass the written test, so the written test probability is 0.8. If the student fails the first attempt on the written test, then the probability they'll pass is going to be 0.6 on the second attempt for the written. Now the probability that a student will pass the practical test is always 0.3. Okay? So the first thing is it says to draw a tree diagram and illustrating a situation and show all the probabilities on the branches. So what I want you to do is I want you to pause this and see if you can't come up with that. And then after you're done, start it back up again. And then we'll take a look and compare. Okay, so hopefully you did that. We're going to start here with the probability tree. We've got the written test. Now, we've got to make sure that we're clear about what's going on here. So let's go over here and do this here. With the written test. All right. Now, this is for the written test. I'm going to make sure that I got this clearly labeled. And there's 2 possibilities. Either you pass or you fail. Now, you'll notice that sometimes I'll use like the complement of something, pass and not pass. In the problem, they use the words pass and fail, and that's the reason I'm using this. So there's our first thing. Now, what happens after the written is that, well, we know what happens if you fail it. If you fail it, then you get a second attempt at the written. So what's going to happen is if I fail it, well, here, let's get our probabilities first. Our probability is 0.8, which means it's 0.2 to fail. Now, if I do fail it, I get a second attempt. Now, again, I need to make sure that I'm clear about this, so I'm going to write written, and again, pass and fail. Now on the second attempt, it's a 0.6% chance to pass it, which means there's a 0.4% that I'm going to fail it. Now let's go back up here, because now I've got 2 scenarios where I passed. If I pass on the first go round, well, what's going to happen is I'm going to take the practical. And see, you can see how important it is to label what's going on. because with passes and fails, you wouldn't be able to tell what the branches represent. So what happens is that if I pass the written, then I go on to it's always 0.3, which means it's going to 0.3 to pass, and that means it's going to be 0.7 to fail. Now, if I failed it, it stops. If I failed the written test 2 times, fail, then it stops. But if I pass it, well, then what's going to happen is that I can take the practical and again, it's either pass or fail, and it's always a 0.3 probability of passing the practical. So again, this is a little unique in the way it's been laid out. But this is what it would look like. All right. Either I pass the written and then pass the practical. I pass the written and then I fail the practical, because remember, you only take the practical once. Then the possibility is that I fail the practical and I fail it again and then it stops. Or I fail the written and then pass the written, and then I can pass the practical or not. So that's the tree diagram. That's part A. In part B, it says find the probability that a randomly chosen student will succeed in gaining a place at college. Well, keep in mind, the people that go to college or go to the science college are the ones that end up passing both tests. So we're looking for the probability of passing both the practicals. So do me a favor and pause it, and then figure that out, and then start back up again. All right, awesome. Hopefully you did that. We've got some different scenarios here. If I take the written and pass it, and then pass the practical, that's one way this can happen. That's this and this. That makes me go to the science college. Another way this can happen is if I fail it first, but then pass the written, and then pass the practical. And so if you put all that together, multiplying them and add them, you should get 69 over 250, or 0.276 is a probability answer for B. Now see, it says find the probability that a randomly chosen student passes the written test on the first attempt, given that the student succeeds in passing or gaining a place at college. So let's write this a little bit more, using the conditional probability formula. See, I'm going to write this like this. The probability that they pass, find the probability that a random student passes the written test, pass written first attempt. And again, I know it's kind of wordy, but I want to make sure it's clear what I'm finding the probability of. And then it's given that the student, now this is what's telling me that we're doing a conditional probability here, given that the student succeeds in getting a place at college. So I'm just going to put succeeds. College. All right, so keep in mind, when you do a conditional probability, the first thing is I'm going to find the probability of both. Find the probability that this person passes the written on the first attempt and then succeeds at college, which means they pass the practical. Then I'm going to divide by the probability of the given. So, pause it, take a look at that, try it, and then start back up again when you're ready. Okay, awesome. Hopefully you did that. So if I go here and I pass it on the first attempt and then I'm successful, well, that's going to be 0.8 times 0.3. Now, divided by the given, that's success, which, keep in mind, I tell you, they love to do this. We've already found the probability the student is successful or they gain a place at college. They word it a little bit differently, but that's the same thing. That probability is this. You don't have to figure it out again. You don't even have to show how you figured it out again. They expect that you're going to pull it from the previous answer. So then all I got to do is put that in my calculator, stack it up, put the exact same thing, and then I get the answer of 20 over 23, which I would write the fraction, and then write the decimal, which this would round to 3 significant figures to 0.87, because that would go up to a 0, right? Anyway, hopefully that was a good one. Let's take a look at the next. Oh wait, let's look at the rubric. So you can see this is the rubric, and how they're going to apply the points. There's 3 points for the tree. So the first thing is, then get a point. Basically, the whole thing is right. It's fully labeled. Each pair of branches is clearly identifying written and practical, and then the pass and the fail, and there's no additional branches. So it's a fully labeled tree diagram, okay? That's going to get you 1 point. And then one written test branch with all the probabilities or percents are correct. Now, you notice you could get points for using the percents, but you need to use the decimals because that's what we're going to do in our math with it anyway. So if you just get the branches all laid out, that gives you 1 point. If you've got one written branch with the written, say for example this part, that gets you another point. So writing the whole thing and having these probabilities right, that gives you 1 point and then 2 points. And then 2 written tests. So now I've got both of these. And then the probabilities are accurate for these. Then I get my third. All right? So let's take a look then at, you can see here, they've done the same thing. Again, there's a method point. Notice how I show how the answer comes about. Yeah, could I have just typed that whole thing in the calculator? I have to show where this comes from. All right, this is a method point plan. Now, the thing is, quite honestly, if you did just put the answer down, if they could see these numbers on your tree, they very well might give you the benefit of the doubt. But it's just no sense in it in being lazy. And I would have written down like what we did here. Okay? Show what you're going to do in the calculator. Don't got to do anything more than that. I don't need to show them what 0.8 times 0.3 is. And I don't need to show all the rest of it. I just got to write down what the initial thing I'm going to do. And then, of course, the answer, and it can be in a fraction or it can be as a decimal. Now, method, as long as you used, like for example, say for example you had the wrong percentages here. If you used the wrong percentages, but you did them in the right way, and you could have gotten the right answer, then you can get this point. Now, there's no way you can get this point if the probabilities are wrong, but you can get 1 out of the 2 points. And so then the next thing here is, you'll see we have our thing, and again, the method is using the probability. All right, this is winning or written on the first one, and passing the practical. And again, we show that. You don't need to show this, but that is what they're looking for. And see the reading, this, there, B. You'll notice that whatever you got here, they're expecting to see that down below here. So you can get the method point as long as this is accurate, and then you use that answer from part A. And then, of course, then you can get both points if you actually have the correct answer. All right, so it's important to understand how these things work. We talk about getting partial credit. You can not get the correct answer and still get decent amounts of points. You could have this tree not set up completely correctly, and you could still get 1 out of these 2 points, and you could still get 1 out of these 2 points, which is better than nothing. So let's take a look here. The next question says, on each day that Alexa goes to work, the probabilities that she travels by bus, train, or car are 0.4, 0.35, and 0.25 respectively. So that means that the bus probability is 0.4, and the train probability is 0.35, and the car is 0.25. And you'd be amazed how many times people mess that up. So if it's me, I'm probably going to pull this out. Probability of bus is going to equal 0.4. Probability of a train. And I'm going to be careful to make sure I don't screw this up. But once I pull it out of the paragraph, I'm far less likely to mess it up. And the probability of going by car is now going to be 0.25. All right, now it says when she travels by bus, the probability that she's late is 0.55. So let's go over here. Probability late when she rides the bus is 0.55. When she travels by train, the probability that she's late is 0.7. Probability she's late is going to be 0.7. Now this is with this. When she travels by car, the probability she's going to be late is going to be X. All right, so the first thing is it says to find X. After they tell you that on a randomly chosen day when Alexa goes to work, the probability that she does not arrive late is 0.48. Now see, I'm going to work on this too. So before you start this, let's make sure we make sense out of this, because I'm not a big fan of this. The probability that she does not arrive late means that she's on time. The probability that she does not arrive late means that the probability of being on time is 0.48. Consequently, the probability of being late is equal to 0.52, because there's only 2 options. Either you're late or you're on time. Whoop, what happened here? You're either late or you're on time. So those are the 2 probabilities, and I'm going to sort that out. So now, go ahead and see if you can lay out a probability tree and then work it backwards so you can figure out what X is. Pause it and then start back up again when you're ready. Okay, so hopefully you did that. Here's what I've got. I've got 3 possibilities. We're going on the train. Well, let's do it in the order I wrote it. We're going on the bus, we're going on the train, or we're going on the car. Bus, train, car. The probability of going on the bus is 0.4. The probability of going on the train is 0.35. And the probability of going on the car is 0.25. Notice when I add these up, this is going to be 100 or 1, right? Now, then there's another pair of possibilities in each case of either being late or being on time. Late or on time. And see, you'll notice how the only word they keep on using is arriving late. They talk about her being late, 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 late. They never use the words on time. So I'm saying the focus here is on being late. So I'm saying late or not late. Late or not late. Late or not late. So the probability of taking the bus and being late, 0.55. That means the probability of not being late is 0.45. The probability of being late on the train is 0.7. That means that not being late is 0.3. And then on the car, the probability of being late is 0.25, which means the probability of not being late, whoops. No, that's not it. The probability of being late is x. Oops, let's go backwards. The probability of being late after the car is x, which means, let's make sure I got that right. The probability that she arrives late is x. So that means not being late is going to be 1 minus x. Now what they tell me is that on a random day when she does not arrive late, which means she's on time, is 0.48. So I've got both of these, all right? Now, you'll notice the late is the part that has the x. So what I'm going to do is I'm going to formulate a question about being late. So here we go. Here's my equation. I'm going to put together all the scenarios where the person's late. So the first one is take the bus and be late. That's going to be 0.4 times 0.55. Okay. The next one is I'm going to do 0.35 times 0.7 times 0.7. And then what I'm going to do is multiply times the probability of being a car and being late, which is going to be plus 0.25 times x. Now, this is when they're late, this is when they're late, this is when they're late. When I put them all together, it should equal 0.52. Now, I could have done on time, which would have been these not lates, and then I would have to use 48, okay? And that's why I think they're trying to use this not arrived late thing, but oh man, it's a terrible double negative. Not late, I don't know, I hate it. So anyway, when I put all this together now, all I gotta do is figure out what x is. This is gonna be 0.22, and this is going to be 0.245 plus 0.25x is equal to 0.52. I'm going to get everything on one side. 0.25x is equal to, if I say take 0.52 and subtract both of those, I'm going to get 0.055. And then if I divide by 0.25, x is going to be 0.22. So that's what I get for that, part A. Now in part B, so let's fill that in. All right, I guess we say this is 0.22 now, right? That way if someone goes and just looks at the end of the video, they won't be able to figure out what's going on, huh? So let's do this, 0.22. And then this one is going to be 0.18? No, 88? 78. Right? Okay, so now, find the probability that Alexa travels to work by train given that she arrives late. So pause that and see if you can come up with an answer for that, and then start back up again. Okay, so let's take a look here. Part B. Find the probability Alexa So let's write this out. The probability that Alexa travels to work by train. So probability that train given that she's late. So just like we did before, I'm going to find the probability that she takes the train and is late and divide by the probability that they're late. Well, this is going to be train and late. That's going to be 0.35 times 0.7. And then we're going to divide by the probability of being late, which we already know. I don't have to really figure it out. 0.52. And when I do that, I get 49 over 104. All right, so let's take a look. If you take a look at the rubric, you get a method point for writing on some kind of equation where you've got the original 0.4 and 0.35 times something. All right, like, let's see here. What are they talking about? 0.4 times 0.35 plus 0.35. So what they're saying is that if you write an equation and you get 0.4 times something that's either 0.45 or 0.55, so one of these two, then you do 0.35 times one of these two, which is 0.7 or 0.3, and then we get this -1, or this is the way we did it with late. You can either use not late or late. All right? So basically what they're saying is, if you kind of set it up right, but you screw up when picking the probabilities of late or not late, you could get a point, a method point. And then you form this linear equation using the sum of three probabilities, and 0.48 or 0.52 is appropriate. So, you know, this is trying to set it up. This is actually getting an equation. And you can get now a point, and again, A means it's got to be the right equation. Either one of these two, okay? And then you get the third point for actually getting the correct answer. So say, for example, you did the method right, you wrote the equation right, but then you got the wrong answer, you would get 2 out of 3 points. And in this situation, if you just write 0.2, in most cases, I don't think you're going to get a point unless there's some work to back it up. And then here you can see where we got this thing. And again, 0.52, this is the same thing. We already know. 1 minus 0.48. I mean, you don't need to write this. I mean, I did. You don't need to write it. What I would tell you is that if you get in the habit of writing it, it's going to take you about 2 seconds longer to do that. And it makes it really clear that you understand what's going on, and the person that's grading is going to operate from the premise that you know what's going on. Don't make them fish around for the numbers and figure out what you're doing. Especially if you've written this and some of your probabilities are wrong, at least they're going to have a pretty good idea that you're trying to use the right method. And then, of course, I'm going to get the right answer. Okay, so let's take a look now at the next one. This is an interesting question because it's actually from the next chapter. It refers to setting up a probability distribution table. All right, now a probability distribution table is basically a table that lists every possibility and then its probability. So the reason I include it is because it's an awesome a situation of where you do have to find probability. And this is where this chapter is going to build into that next chapter. You have to use these probability skills in this kind of problem. Now, we'll only do part A. There's probably other parts that we're not going to be able to do. So anyway, let's go ahead and think about this. I got a fair spinner. It's got sides 1, 2, and 2. And see, again, we've had situations like this before. A dice or a couple spinners. The second spinner, -2, 0, and 1. Set up a possibilities table. Now, it says that each spinner is spun. The number on the side which a spinner comes to rest is noted. The random variable x is the sum of the two numbers. So those are the things we have to find, the probabilities. So this probability distribution table is literally just going to have all the numbers that could possibly come up and then their probabilities. So, and keep in mind, these numbers have to be the sums. So what I want you to do then is fill in this table, find the sums. There's going to be 9 of them. And then show me the probability of each one of the numbers coming up. Pause it and start back up again. Okay, so hopefully you did that. If we're adding these together, this is going to be a -1, this is going to be a 0, this is going to be a 0, this is going to be a 1, a 2, a 2, this is going to be a 2, this is going to be a 3, this is going to be a 3. So again, I know this is kind of weird, but we're not going to worry about the table part. What's the probability of getting a -1? Well, it's going to be 1 out of 9. What's the probability of getting a 0? That's going to be 2 out of 9. What's the probability of getting a 1? That's going to be 1 out of 9. What's the probability of getting a 2? That's going to be, let's see, 1, 2, 3 out of 9. And 1/3. And don't, for some reason, for probabilities, it's not the end of the world if you don't reduce the fraction. There's reasons for that, which we'll get to when we get to the next chapter. And then the last possible thing that could have come up is 3. What's the probability of getting a 3? Well, there was 2 of them, so the probability is 2 out of 9. Now, this is not that complicated of a problem, but we've just figured out 5 probabilities pretty quickly and pretty easily using this possibility table. And then, like I said, when you get to the next chapter, literally all we do is set it up in a table form, which again, we're not going to worry about right now. All right, so hope that made sense. Let's take a look at this next one. Oh, wait, let's see how that scored. Okay, so here I'm even going to show you. I forgot that. I keep on forgetting I have this on here. So here, notice how these are the possible things that could have happened. A -1, a 0, a 1, a 2, and a 3. Those are the only things going to happen in this situation that they described. They're the only numbers in the middle. And then we found the probability of each one. 1/9, 2/9, 1/9, 3/9. Notice how they don't simplify it. And then 2/9. And again, in this situation, this was worth 3 points. All you had to do was find some probabilities. Set up the table with at least one correct probability, and you could be good. 2 probabilities get you another point, and 3 correct probabilities with correct outcomes. 3 further. All right, so basically, let's see. 1, 2, at least 1. There's at least 2. And then here we have 3 furthermore, so that means all 5. So basically you get the third point if it's pretty much all right. So you could screw up on some of this, but let's face it, there's no reason to screw up on any of that. All right, take a look at this one. I've got a fair-sided die, and it's each face is marked 1, 2, 3, 4, 5, 6, just like a regular die, a square, cube die. But there are three of them, and they're thrown at the same time, repeatedly. For a single throw of 3 dice, the score is the sum of all the 3 top faces. Find the probability that the score is a 4 on a single throw of 3 dice. Now keep in mind, whenever they talk about throwing 3 dice at one time, well, it's always going to be a sequence, okay? So they may say we threw all 3 dice at one time. It's the same thing as throwing 1 die, throwing another die, and throwing another die. Or, in fact, it's the same thing as throwing 1 die 3 times. So let's look at it from that standpoint. Now, the probability of adding up all 3 die and getting a 4. If you think about it, there really aren't that many ways for this to happen. So what we're going to do is we're going to start at an extreme. So I'm going to say that on my first throw, I got a 1. Now, on my second throw, now again, I'm thinking of this as a first throw, second throw, and third throw situation, okay? If on the first throw I get a 1, well, then if I get another 1, I could possibly get a 2, and the whole thing is going to equal 4, all right? That's going to be 1/6 times 1/6 times 1/6. Now, what's the probability of getting a 4 on a single score of 3 die? The answer is not 1/216. Pause it, finish it, and then start back up again. Okay, so hopefully you didn't have to pause it very long. So keep in mind, the way I look at this, there is more than one way for this to happen. And this is, again, since we're talking about arrangements, I've got 3 numbers. 2 of them are identical. What's 3 factorial divided by 2 factorial? It's going to be 1, 2, 3, right? 3 times 2 times 1 divided by 2 times 1. There's 3 different ways this can happen, okay? And it's pretty simple if you can see it. If the first one was a 1, and the second one was a 2, and the third one was a 1, or if the first one was a 2, and the second was a 1, and the third one was a 1, they're the only ways I can get a 4, okay? So basically what happens is that if I want to know the probability of scoring a 4 when I throw 3 dice, it could happen 3 different ways. 1-1-2, 1-2-1, or 2-1-1. So if I just multiply this times 3, it's going to give me 3/216, which is 1/72. All right. And let's take a look and see if I got a rubric for this one. Yeah, I do. See, notice method point. You need to show somehow that you did 1/6 times 1/6 times 1/6. You show the possible cases. That's going to help you. And then times 3. Okay, these are the methods. Multiplying by 3, not by plus or minus. Okay, so you can get a multiple. So for example, so you just do this. That gets you 1 method point. You take that answer, multiply it by 3. That gives you another method point. Get the correct answer, and that gives you all 3 points. But like I said, you can see how it's possible that somebody just be able to figure out immediately by looking at this that it would be, the answer would be this times 3. Don't just write the answer 1 over 72. They need to see some of this work. You don't need to see tons of it, but we do need to see some of the background work. All right. Take a look at this one. It's a table. They give us a table. This happens every once in a while. I think this is probably one of the easiest situations of probabilities. But take a read through it. The words just kind of validates it. What is interesting here is they do tell you that the total number of households in the 3 villages, here are the 3 villages, Rita, Sean, and Tiber, is 800. So that means if I add up all these numbers, it's going to equal 800. All right? So read through that, and then take a look at probability A1 and A2, and see if you can't figure it out. And then start back up again when you're ready. Okay, so hopefully you did that. Let's take a look. Find the probability that a randomly chosen household is in Sean and has poor broadband. So I need them to meet both criteria. This is the probability that it's S and poor. Okay? Now, I'm going to just find what meets both characteristics. They have to be here, so it has to be in this row, and it has to be poor, so that means that it's going to be 40. This meets both criteria of being from Sean and having poor Wi-Fi or broadband, and so the probability that that happens is going to be 40 out of 800, or 1/20th. Now the second one. Find the probability that a randomly chosen household has good broadband service given, and see, this is telling me we got a conditional probability that a household is in Sean. Okay, so let's try this. First, we're going to write this out. The probability that a randomly chosen household has good broadband, so I'm just going to probably being good, given they're from Sean. Okay, so the first thing is I need to find the probability of it being good and from Sean. Why do I write 6 instead of G? And then divided by the probability of being from Sean. Now there's 2 ways to approach this. You could use the formula, or you could just go straight to the table. Let's try just going straight to the table. If it's given that the household is from Sean, well, that means I only really need to consider these numbers. It's given that they're from Sean. All right? So now, all I got to do is figure out, where do we have good broadband? 177. Now the thing is, it's given that they're from Sean, so I'm not dividing by 800. I'm dividing by all these put together. So this is going to be 177 divided by 223 plus 177 plus 40, which should be 177 over 440, okay, which equals 0.402. If it's given that they're from Sean, then you can forget about everything else. And so all you're going to do is take the 177 and divide it by the number of people in Sean. Okay? Now, we could use the formula that we were using. What if the probability that it is good and from Sean, well, that's going to be 177 over 800. All right, now let's make sure we're clear about this. It's good and from Sean. All right, that's 177 out of 800. Okay, and now we're going to divide by the given. which is they're from Sean, which means we're going to take all these and add them up. And that's going to be, the probability they're from Sean is going to be 440 divided by 800. And if you want, you can multiply by the reciprocal, or you can just realize when I divide a fraction by a fraction, if the denominators are both the same, it ends up being the same thing as removing the two denominators. These cancel out. It ends up being 177 over 400. So if you're going to use the table, you could just write this, and that's going to be fine. If you want to use the formula, then you're going to write this, and again, this is a little bit more work, but it's going to be fine. Doesn't make a difference. Both get you the right answer. Let's take a look at the rubric. So again, you'll notice they'll accept 40 over 800, or a 1 over 20, or 0.05 if it's been, that must be three figures. Okay, so in this first one, you just got to give them the right answer. Okay, and that's why I'm saying I'm going to write this, and then I'm going to reduce it. I might even put the decimal. If I screw up writing one down wrong, I'm increasing my chances that one of them is going to be right. All right. If in the second part, you'll notice how they've done this. This is one method, and again, here's the alternative method. I could take it off the table. This is what we did first, or I could use the formula. Either one is going to be fine. You have to demonstrate your method, so you have to show what you're using the numbers and then get an answer. All right? So either way, the nice thing about a lot of these problems is there's more than one way to do it. Quite honestly, I don't always, in these rubrics, put all the different possibilities, but there's a couple there. All right, so here, this one. The score when two fair six-sided dice is thrown is the sum of the two numbers on the upper faces. Show the probability that the score is 4 is 1/12. Now, we talked about this. You could go ahead and build a possibilities table doing 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. But in this case, there's only a part A. There isn't a part B. There isn't more to do. There's only the one thing. So what I'm going to do in this case, instead of writing down all that stuff, I'm going to see how difficult it is to figure out how many ways I can come up with a 4 with two dice. So if you think about it, there aren't that many ways. Start with a 1. If I get a 1 and a 3, if I get a 3 and a 1, and the only other way I can come up with a 4 is to get a 2 and a 2. Those are the only 3 ways I can come up with. And, is there a chance that I've missed some? Yeah, but just think about it. If I add a 3 and a number, it's going to be 1. If 4, that's too big. I only can get a 4. So these are it. So now all I got to do is figure out the probabilities of those things happening. So this is 1/6, 1/6. This is 1/6, 1/6, 1/6, 1/6. Oops, times it. Whoops, back up. So here, this is going to make me happy because it's a 4. This is going to make me happy, so it's a 4. I'm going to take these and add them up. Or if you want, you can do 1 over 36, which is 1/6 times 1/6. And then multiply it times 3, which gives you 3 over 36, which gives you 1/12. Either way, but you could show this or you could do this. All I'm saying is, if you only have to do one thing, as long as you're careful, it may not be worth making up this whole possibilities table. And let's look at the rubric here. It's only worth 1 point, so they're pretty much looking for this answer. Okay? But that's where it comes from. All right. So let's take a look at this one now. Company produces small boxes of sweets. I got 5 jellies and 3 chocolates. Jamil chooses 3 sweets at random from a box. Okay, this is another probability distribution problem. And again, the first step in doing these probability distribution problems is finding the probability of each thing that could happen. So let's think about it. If the company makes these small boxes of sweets and they contain 5 jellies and 3 chocolates, so imagine I've got 5 jellies and 3 chocolates in a bag or in a box, one box, and I randomly pick out 3 pieces of candy. What are the possible things that could happen? Well, the least possible is, and again, the thing I'm interested in is the number of jellies, okay? Well, one possibility is that there are no jellies, because there are 3 chocolates, and it's possible that I pull out only 3 chocolates when I pull out my 3 pieces of candy. It's possible that I only get 1 jelly. It's possible that I get 2 jellies. And the last possibility is I get 3 jellies. I'm only taking out 3 pieces of candy. So basically, when I'm setting up this table, these are the things that are going to go across the top, and then I need to find the probability of each one of those things happening. All right, so let's think about it. Oh, and I know the reason I chose this. You can do this, but what I like about this is that we can use combinations to do this. All right? Whenever you have a situation where they're finding probabilities and they are choosing or selecting things out of these possibilities, well, let's try this. First, if I have no jellies, remember this is about jellies, okay? Well, that means I did 5, choose 0 jellies, which means I did times 3, choose 3, okay? This is the number of ways I can pick 3 pieces of chocolate out of 8 pieces of jellies or 5 pieces of jellies and 3 pieces of chocolate, right? Now, how do I find the number of ways I could pick? Well, I've got 8 pieces of candy, and this tells me the number of ways I could choose 3 of them. So then all I got to do is type that up in my calculator and then find the answer. Try this one. If I want the probability of selecting 1 jelly out of the 3, well, there were 5 jellies. That's me picking 1 of them. That's how many ways that could happen. Times, now, if I got 1 jelly, I don't need to pick 3 chocolates. I just need to pick 2. Because the requirements is I pick 3 pieces of candy. And see, this number will be the same. All right? Pause that. And then see if you can't figure out the answers to these 2 and then the next 2. And then start back up again. Oh, and let me give you a hint. If you enter it in the calculator exactly this way for this one, get your answer, then go back and change these 2 numbers from 3 to 2 and from 0 to 1, and then just press enter and get a new answer, and then do the same thing for this setup. You shouldn't have to rewrite the whole thing. Just use your thing, arrow back, and then put in the numbers. Start back up again when you're ready. All right, so hopefully you did that. Here's the answers I come up with for these. I've got 1 over 56 for this one. I've got 15 over 56 for this one. Here, this is going to be 5 choose 2 times 3 choose 1 over 8 choose 3. That I have 15 over 28. And then the last one is going to be 5 choose 3. That's where I get all 3 jellies. 3 choose 0, all divided by 8 choose 3. And that one I get is 5/28. All right. And That's the answer for that one. Just a little side tick. You notice if I did make these denominators all the same, this would end up being 30 over 56. This would end up being, because I'm doubling this, right? So that means this would be 10 over 56. 10 plus 30 is 40. 40 plus 15 is going to be, or 40 is 55. Plus 1 is 56. Do you notice if I add all these up, I end up with 56 over 56. When I do a probability distribution table, because I find the probabilities of all the different possibilities, well then, it's all going to add up to 1. Awesome, right? Okay, so let's take a look at another one. Oh wait, here's the rubric. Sorry, I keep on forgetting. So, you notice they've done this. I didn't put the other possibilities, but if you wrote down this, they're going to accept it. They're the same answers. Look, 1 over 56, 15 over 56, 30 over 56, 10 over 56. And don't get me wrong, just because they have them all the same, they would have accepted these answers just fine. All right, so setting up the table, that gives you the answers. And then there's going to be more work to do for here, showing these different probabilities. That's the method points. And again, this was one way to do it, but I think that the combinations is kind of an interesting way. You see what's happening here is that the probability of getting 0, well, that's going to be 3 out of 8, because there's 3 chocolates and 5 jellies. But then the next one, there's only going to be 2 times 7, and then 1 times 6. If I wanted the probability of getting 1 jelly, well, that's going to be 5 out of 8. That gets me my jelly. And then 3 out of 7, because there's 3 chocolates, and then 2 out of 6, because now there's only 2 chocolates. The thing is, though, then I've got to multiply it times 3, because they can be switched around. Boom, boom, boom. Anyway. Let's take a look at this. On Mondays, Randy cooks evening meal. She has pizza, a burger, or a curry with the probabilities of 0.35, 0.44, 0.21 respectively. When she cooks pizza, Randy has some fruit with the probability of 0.3. When she cooks burger, she has some fruit with probability of 0.8. When she cooks curry, she never has any fruit. So, what I want you to do is pause this and try coming up with a probability tree. And then we'll start back up again and compare. Okay, so hopefully you did that. Here's what I've got. I've got 3 different choices for my A. She either makes pizza, burger, or curry. Pizza, burger, curry. Probability 0.35 pizza. Probability 0.44 burger. Probability 0.21 curry. Now, probability that she has fruit. I'm just going to do fruit, no fruit. Fruit, no fruit. Fruit, no fruit. Now, probability she has fruit when she has pizza is 0.3. So that means no fruit is 0.7. Probability she has fruit when she has a burger is 0.8. That means no fruit is 0.2. Now, the probability that she has fruit when she has curry is never. So she has no chance of having fruit after having curry. The probability that she does not have fruit is going to be 1 because it's absolutely going to happen that she's not going to eat fruit. So your probability tree should look like this. Now it says find the probability that Rainey eats some fruit. Well, that means we need to find the probability of this one and this one and, well, you can put it on there, but you see what happens. Pause it and start back up again. Tell me what you get. Okay, hopefully you did that. So basically for B, what we're going to do is we're going to find the probability with some fruit. Well, that's going to be 0.35. Here, there's fruit. Times 0.3. Here, there's some fruit. And then here, you'll notice that even though I could get curry, I'm going to multiply it by 0. So you could leave that off if you wanted to. So basically all we got to do is put these two together, and hopefully you got 0.457. All right, now C, find the probability that Randy does not have a burger given that she does not have any fruit. Pause it and start back up again after you figure it out. Okay, so for C, let's see, find the probability. Let's write our formula. Probability, if they are not having a burger, that means that they are having pizza or curry. So I want to find the probability to have pizza or curry given there's no fruit. So we need to find the probability of both having pizza and no fruit or curry and no fruit. That goes on the top. So let's see. Probability of having pizza and no fruit. That's 0.35 times 0.7. The possibility of having curry and no fruit. Well, that's going to be 0.21 times 1, which is going to be 0.21. Now, the probability, that's the probability of having pizza and no fruit or curry and no fruit. Now we're going to divide by the probability of having no fruit. Now we can go and figure all that out, but since we already know the probability of having some fruit is this, that this must be no fruit, must be 1 minus it. So what would end up happening is you'll end up getting 0.455 over 0.543, which will be 0.838, or maybe you put the fraction 455 over 543. Okay, so let's take a look at the rubric. The tree was labeled worth 2 points because it's a pretty basic tree. Let's see what they said. Fully correct labeled tree, correct probabilities, 1 point. Fully labeled branches with probability for lateness. With either one branch, fully labeled. All right, so it's not lateness, it's fruit or not fruit. All right, but so this rubric looks a little messed up. But anyway, it's fruit or no fruit. Someone's not read the whole problem when they're doing this rubric. All right, so fully collect branches, correct probabilities, with either one branch with W or 2 branches with probability of 0. Oh, I'm not really sure what that's talking about. This looks like it's screwed up. And this is actually off the test rubric, but they make mistakes, so they're human. I'm sure they caught it and they made an adjustment when they were doing the tests. Okay, so that is worth 2 points. The weird part about this is this right here, the fact that there's no chance and there's 100% chance. That doesn't always happen. And then the last one here, well, we've got our method points for we multiply, and we add. That gives us a 0.457. And then the last part, the conditional probability. Again, this is what we did, this is what we got, and then what's the answer we got. So method, you're showing that you're doing this. Now, they have this point written up here. It doesn't mean that if you just write this formula that you're going to get a point. But if you are trying to use that formula and then you have this part wrong, well, then you're going to get the method point. And then you can get a method point down here for adding up the 3 appropriate factors consistent with the tree diagram. Okay, so if your tree diagram isn't accurate, you can still get a point here if you used your figures. You can get a method point here if you use your figures from your tree. And of course then the method that you have to get the last point is going to be 1 if you get the right answer, right? Okay, so that's all I got for you today. I appreciate you watching this. Hopefully it helped. Have an awesome day.